Okay, our subject for today is going to be human population dynamics. And you might wonder why we're interested in human population dynamics when we're talking about a crop science course. But there's a definite relationship between numbers of people and the amount of food that they need to consume. And the fact is that most of our production in crop science is directed toward food production. So it's a very important relationship. And one of the most important things we have to be aware of is the connection between human population and periods of starvation in our history. It's important to look back and see when we've gone through periods of history when we had starvation on a fairly large scale, and what maybe were some of the causes of that, and because we certainly don't want things like that to be happening in the future. So we know that even before the agricultural revolution, and since the agricultural revolution, there have been episodes of starvation. Most of these episodes are fairly localized. They're localized to certain parts of the world or certain parts of certain countries, not a widespread. We haven't really had a widespread planet-wide famine yet. We haven't had one yet, and we hope that that doesn't occur. But we do have periodic small-scale famines. It's interesting to point out that according to a recent Nobel Prize winner, no famine has ever occurred in a country with a functioning democracy. In fact, the Netherlands have been the country that's gone the longest. They were the first to eliminate famine in the early 17th century, and they do have a functioning democracy in the Netherlands. Some episodes of starvation that have occurred throughout history, and you can look at some of the causes of this. During the famine of 436 BC, thousands of Romans, and this of course is in the very early part of the Roman Empire and the establishment of Rome as a world center for trade and domination. They threw themselves into the river rather than starve to death, because that's what they were facing at that time. During the Great period in Europe where there were a lot of bad weather, this is partly related to the little ice age that occurred during this time. They had a lot of bad weather, a lot of crop failure. Millions of people died of starvation. During 1315 to 1322, the population of the country diminished by the population of Europe, that is, diminished by one half. In India, 1291. Whole families, again, drowned themselves to avoid starvation. And you can Google all this kind of stuff and look it all up if you want to. 14 famines were recorded between the 11th and 17th century in Europe. Again, a lot of that was due to the adverse weather effects of the Little Ice Age. But we've had other things. 3 to 4 million people died in Bengal, India during a famine during World War I. In Ireland, one of the most famous things that we've had happen that affected us directly here in the U.S. Was the Irish potato famine, the largest famine in proportion to the population at that time. 1 million people died, and this is a country of about 4 or 5 million people. About half of them left, and about the other half of the people who were gone, about half of them died, and about half of them left Ireland during that time. Many immigrated to the U.S. during this time because of the failure of one crop. It's pretty interesting that you have a country like Ireland, and this is how it gets to the distribution of food. You have a country like Ireland that is sitting right next to a country like England, but there was no English famine, there was no English potato famine, and the Englishmen were well fed during this period, but the Irish starved to death primarily because the Irish people depended upon one crop, the potato, for the majority of their subsistence. They grew a lot of other crops, but because they were under the control of the English at that time, and a lot of the land was held in absentia by English lords, most of that production went to England, and so they produced food but were not able to consume it. In China, they had a drought in 1876 to 1879 that killed 13 million people. Vietnam in 1945, 2 million people died from starvation due to Japanese occupation. Most famously lately was the Great Leap Forward in China. Most Americans are not aware of this. Of course, the Chinese certainly did not publicize this, but between 1958 and 1960, They don't know how many people died of starvation. They estimate it to be between 14 and 43 million people, mostly in the countryside. They some estimates go as high as 50 million people, but again, the Chinese government did not publicize this too much. They did not want outside help. They were in the process of trying to modernize China in a very rapid way. The Chinese revolutionaries, the Mao Zedong government, was trying to modernize China, and basically what they did was it's a very complex issue how so many people could die of starvation in a country that produces as much as China did. But again, they were in a situation where they produced plenty of grain, but most of that grain was confiscated by the government, sold by the government to other countries, used in the cities, and the people in the countryside were left literally to starve to death. In fact, they even took away, in a lot of cases, their means of cooking food. They went around and collected most of the iron pots and things that people were using at that time to cook. The government had other ideas, and they were not even aware in a lot of cases. It's funny, the most interesting aspect of this to me in reading a book about this called Tombstone is the name of the book. When the government in Beijing and other city seats realized what was happening out in the country, they still did not send food out to these people. They sent medical teams to treat the starving. Medicine's not going to do much good when a person is starving to death. Other estimates of our current situation are that 500 million people suffer severe hunger and malnutrition at any one given time on this planet on a day-to-day basis. 20% of developing world's population is chronically undernourished. 30 years ago, it was about 40%. So we're beginning to make some progress. We're seeing some progress in this area. A child dies of hunger every 6 seconds. Hunger now kills more people every year than AIDS, malaria, and tuberculosis combined. And when you look at some of these diseases like AIDS and malaria and tuberculosis, while they're significant problems for our human population, they do not kill significantly numbers of people compared to hunger. And we still have, a lot of hunger today. 925 million people experience some hunger of some sort, and primarily they lack access to sufficient quantities of the major food groups of humans: the carbohydrates, the fats, one or the other of these, and protein. Protein is usually the biggest, the part of the human diet that is in the shortest supply. Another billion, and we do have about a population of about 7 billion people on the earth, so about 1 in 7 are thought to suffer from some sort of hidden hunger. Vitamins and minerals, vitamin A deficiency is very common on this planet, something that could be eliminated very easily. And then you've got 1 billion people on this planet that are substantially over-consuming, not only food but alcohol and drugs, that most of which have to have the same resources to produce that food does, involving causing a new public health epidemic involving chronic conditions. Type 2 diabetes is an epidemic in this country. Cardiovascular disease, heart disease, is also an epidemic in this country as well as many other countries in the world. And again, most of the responsibility for these 3 billion out of 7 billion people having suboptimal diets, whether it's too much or too little, lies within the global food system. It's not the lack of production, it is the way that food is distributed and the economic factors that drive that distribution of food. So, in 1798, there was an English clergyman by the name of Thomas Malthus. He wanted, at that time, he was a very observant guy, and he wanted to put the concept of an expanding population. He realized at that time that the human population was expanding, and he also realized that food production could only expand at a rate, at a predictable rate, generally at a linear rate. So he attempted to put all this into mathematical forms, into a mathematical terms or mathematical theory. So he looked at the linear part here, which are resources for food production, and this is how he looked at the increase in food production occurring is in a linear way, gradually in a straight line way. He also observed that human population growth tended to increase in a curvilinear way, slowly at first, and then rapidly picking up as more and more people were born until you went in. And you have, even in a curve like this, you have various parts that are relatively linear, but when you put it all together, you get a curvilinear response here. So over time, and time is what is along the x-axis here, as we go forward, he theorized that the human population increase would outstrip the ability of the planet to produce food. So you would induce here a point of crisis where the population would increase to a point where there was not enough food here to support the human population that was there. So he made a prediction based on this unchanging linear curve that he perceived would be the food supply, that we would have points here where the population would increase and go beyond that and outstrip that. You would have then a resulting famine at this point, in which case the population would be reduced back down to below what the food supply could support or the planet could support based on resources for food production. And then again, you would have another famine at some point in the future where the human population would again decrease, again start to rise, and give you yet another famine. He predicted these periodic famines that would occur when the human population outstripped the ability of the planet to supply food. So population would necessarily then, according to Malthus' theory, population of the planet would necessarily be limited by the available food supply. So let's look at how world population growth has changed over the years and how it has grown. In the Christian era, we had a population on this planet. This would be about 0 BC, about the time of the Roman Empire and all the things that were going on in the world about that time. And of course, we tend to think of these things in European and Western thought, but there's a lot of people in Asia living in Asia at this particular time too. A lot of empires rising and falling there. But the population of the earth was around 250 million people. So during the Christian era, we had about 250 million people, and that would be about the little less than the current population in the United States. We have more than that now in the United States. By 1650, this had grown to 500 million people. So you had a doubling time here of about 1,650 years to go between 250 to 500 million people. And then by 1850, it had doubled again. So that at 1850, the population of the entire planet was about equal to today's population of China. And then by 1930, we got another doubling, up to 2 billion. And then 1975, it doubled again, only 45 years later. It took 45 years to double to 4 billion. So again, we are seeing this population growth curve that Malthus predicted. By 2007, we were at 6.5 billion. By 2013, we were at 7 billion. And by the year 2020, we predict it will hit a population of about 8 billion. So it took us 2 million years from the first humans to get to a population of 4 billion here. And then it's only going to take us 40 years to go from here, about 40 years to go from here to double that population, to add an additional 4 billion people to the planet. It's going to only take another 40 years. So our population growth is increasing at an increasing rate. It's increasing very, very rapidly. Where does this most of this population growth increase? Where does most of this increase occur? It occurs mostly in developing countries. Not all of it, but most of it's going to be in developing countries. And to give you some example, if you can look up, it's easy to look up, for example, the growth rate of countries. But what does that number mean? Well, if you have a growth rate of 1%, it takes 69 years to double. At a growth rate of 2%, we double the population every 35 years. At a growth rate of 3%, in other words, increasing the population by 3% every year, So if you've got 100 people, by the end of that year, you would have 103. That's a 3% growth rate. It takes only 23 years to double the population of a country or anything that's growing. And this doesn't matter what you're measuring here. The growth rate of 3% will cause a doubling in 23 years, even if you're talking about people or money. If you invest your money at 3%, then in 23 years it will have doubled in value. In a period of 100 years, at a 3% growth rate, your population will go up by a factor of 19 times. So you can figure all this out. If you don't believe me, you can put the numbers on the paper and look at it and see. How do you figure out this doubling time? We use the rule of 72. The rule of 72 is a good thing that people like to use when they're calculating how long it's going to take to double their money. If you take 72 and divide it by the percent increase, in this case 72 divided by a 3% increase, you get 24. This is just an approximation. We said up here that it was 23, but the rule of 72 would tell you that it was 24. So it's a close enough approximation. Some of these countries, many of these countries, you can Google this and you get this information very easily. Some of these countries are experiencing population growth rates in excess of 3%. I gave a 3% value here and told you the population would double in 23 years. Many countries have population growth rates in excess of 3.5%. India, for example, adds the equivalent of the population of Australia every year. These are some of the countries. This is where a lot of the growth is occurring here when you look at births per 1,000. Of course, this doesn't tell you what the growth rate is. It just tells you how many people are having children and what the birth number is. You have to offset that with the deaths, of course, and this does not reflect that. It's just births. But you see where most of the births are occurring in our world. They're occurring here in Africa, Central Africa, and in certain parts of Asia. Anything that's in yellow, brown, anything that has a greenish tint here, these countries, India, for example, here's China over here. China is slowing down its population growth. Is doing a good job. Some of these countries here, Germany, for example, Italy, Portugal, even Canada, Japan, for example, famously over here in our hemisphere, Cuba, are experiencing very, very slow and even negative population growth rates. And here are the world fertility rates. These are births per women. These numbers sometimes are hard to get your head around, how you can have countries here where women on average are having 7 to 8 children. But there are many of them, 7 to 8 children per woman on average in some of these countries. Here's Somalia, and in other countries, many of these African countries, Nigeria, for example, very, very high birth rates for women. It's been shown that there's a direct correlation between the amount of education a woman gets and the number of children she will have. The more education she has, the less number of children she will have. A lot of these places particularly do not value a woman getting any sort of education at all. If we look at the future growth on the planet, we know that 50% of the future growth between now and 2050, we're expecting in 2050 a population on this planet of 10 billion by 2050. And from between now and 2050. And so we're going to increase the world population by about 2.5 billion between now and 2050. This is a 2.5 billion increase. And if we look at the countries where this is going to occur, about half of this 2.5 billion is going to come from 9 countries. And of those countries, I'll just list them here and then tell you something in general about them. These are going to be India, Uganda, Nigeria, Pakistan, the Democratic Republic of the Congo, Ethiopia, United Republic of Tanzania, Indonesia, and last but not least, the USA. Now, 5 of these countries that I've listed are in Africa. 3 are in Asia. Here, Indonesia, Only one of the countries that I mentioned is a developed country, and that is the U.S. And most of our and this is the reason why it's not reflected in terms of fertility rates nor in births per 1,000. Most of our increase is going to become about as a result of immigration. So people are moving from some of these countries where there is a lot of population, particularly Asia and Africa, and are immigrating to the U.S. And we're getting a lot of our increase in population there. So most of this impact, most of this increase in human population is going to be occurring in countries that can at least afford it. That makes this a global issue, and it's a global issue for us because we are probably going to be the ones who are going to have to deal with it. We're already having to deal with it to some degree, but we're going to have to deal with it even more as the future goes forward. Why do these underdeveloped countries have such high growth rates? Well, if you look at the way developed countries have progressed, and you look at the births per thousand, we see that that's been on the decline. The births per thousand people in developed, and we're talking about developed countries here like the U.S., the birth rate has gone down. Death rate has also gone down. Now, the death rate is kind of a funny statistic because you figure that the death rate is actually 100%. All of us are going to die at some point. But the way they look at deaths here is deaths per 1,000 in a given year. And that has declined. Primarily in most of these developed countries, it has declined, and in developing countries as well, has declined due to decreases in infant mortality. If you go back 100 years, it was not uncommon for infants to die at all. You could go. I took a trip to Scotland a few years back and visited while I was traveling around the countryside there. Visited some graveyards, and it was interesting to me to find family plots where there would be a mother and father buried, and then their children would all be buried there with them. 3, 4, 5 children that died maybe within a span of 2 years after being born. Not uncommon at all. Today it's a tragedy, and we, as a result of getting rid of the problem of infant mortality through better medicine, we have decreased the birth rate, and it is this difference here that is the actual growth rate. This difference between the birth rate and the number of deaths that are occurring in the population. This is the growth rate over time. So if we look at the same situation in developing countries, we see that their birth rates have not changed. They are still having births at certain rates that are going to cause a big gap here between the death rate and the birth rate. And of course, in some of these countries, they have had decreases in the death rates also due to improved medicine and reduction in infant mortality. So, but it causes a very much larger growth rate here in these developing countries. So why didn't the predictions of Malthus come true? This is one of the things we need to deal with. Malthus predicted periodic famine in 1798, and so far we haven't seen that on the planet. We've seen certainly, it gets in the news once in a while. A country like Ethiopia or Somalia or one of these African countries will experience a famine. Most of the time we don't hear about it at all if it's on a small scale. But even if it's on a bigger scale, we might hear about it, and there are people that are trying to do something about it, but it does not affect us directly. So we haven't had the kind of famine that Malthus predicted, the kind of worldwide famine. And there are some reasons for this. One of them is the Industrial Revolution. Malthus did not foresee the invention of the internal combustion engine, for example, that would make it so much easier to plant, maintain, and harvest crops. Irrigation, for example, is much easier with an internal combustion engine than it would be without. He did not anticipate the finding and developing of new agricultural lands. Remember, this was before the settlement of most of the United States west of the Appalachian Mountains. And so there's vast areas of the United States across the Corn Belt, Nebraska, almost to eastern Colorado and other areas, vast areas of the country, including Canada, very productive. Some of the most productive agricultural lands in the world were developed after the time of Malthus, including some of the best lands in Australia and some of the best lands in countries in South America. So there was a whole lot of land laying out there to be developed for agricultural exploitation that Malthus was not aware of. And then there was improved agricultural technology. When we talk about agricultural technology, we're talking about the use of fertilizers, the use of pesticides, or agricultural chemicals, things like improved refrigeration. And this could be sort of linked to the Industrial Revolution also. It's not only the mechanical harvesting and maintenance of crop fields, it's also the transportation of food, moving food from one place to the other, the preservation, refrigeration, for example, the preservation of food, refrigerated rail cars, railroads in general. All of this stuff was not foreseen by Malthus in terms of the ability of the food production to keep up with rising population. So Malthus was correct in saying that the population was going to rise in a certain way, but he was not correct in assuming that food production could not keep up. We've so far been able pretty much to keep up. Certain areas done a better job than we need to keep up with food production, such that we're able to maintain food production in the face of ever rising population. Some of the predictions for the next 40 years or so: advanced science and technology can permit an adequate food supply for the next several decades, but we must, at some point, and we do, have to get population growth under control. And there are efforts. This is happening in certain parts of the world. Again, certain countries like Japan and Cuba, and certain countries in Eastern Europe and Russia, experiencing negative population growth. It's a concern to them. Some experts estimate that the Earth can support population of 38 to 40 billion people. I don't know where they come up with these types of numbers, why there would be any limit, for example. But you've got to understand that there's a limited number of resources. We're not going to find any new land. We're not going to discover any new sources of water. We're going to have to look at other things to develop new production capabilities for our food systems. So that comes to the end of today's of this particular topic, and next we will be looking at the resources that we have available for crop production.